Hi everybody, this is Mrs. Mancuso, and today I'm going to teach you about how redox reactions are actually used. So, like when you have a battery. When you have a battery, the battery itself is what you call a voltaic cell. And so a voltaic cell is where you do a redox reaction. So you're going to have something that is oxidized and losing electrons, and you're going to have something that is reduced and gaining electrons. And the electrons are going to go through the wire. And when the electrons go through the wire, they are able to send the electricity. So when you have a battery, there is usually two parts inside the battery. So I got to draw it because you wouldn't imagine that all this stuff is inside of a battery, but there's actually two different chambers. And I bet you can guess what one of the metals are inside of a battery. So I want you to do all this in your notes. I want you to draw all this. I want you to label it. This is how you draw a voltaic cell. So draw two beakers right next to each other. Fill them up with liquid. Make a little U-tube that connects their liquid. That is called a salt bridge. Salt bridge is how you transfer ions back and forth. Ions can go back and forth from one side to the other side through the salt bridge. Okay, now I need to say what is in these solutions. So I'm going to say this one is TiNO3 2. That's this solution that's in here. And over here, I'm going to have KNO3. That's the solution in here. And then I have to have two electrodes, which means two pieces of metal, one piece of metal on each side, and the pieces of metal are connected by a wire. So this is the wire that my electricity is going to go through. That's where my electrons are going to go. And I could put a little V, I could connect a little voltmeter to it and be able to measure how much power I make. How much electricity can I generate based on these two metals? So the metal over here, I take the metal from this solution. This metal is Ti, and this metal is K. And that is what my setup looks like. That's what my drawing is. So again, I have two electrodes. I have two separate, they call them half cells. I have two containers that have reactions going on in them. And in order to move forward, I have to use table J. So here's table J. And I am looking for K and Ti. And K is definitely higher, which means K is going to oxidize, and Ti is lower, so this side is going to reduce. So now I can go back to here. So I said this side was going to oxidize, and this side was going to reduce. So oxidation is losing electrons. We call the site of oxidation an anode. So these electrodes, these pieces of metal, have names, anode and cathode. Anox always goes together, and red cat, and cat is short for cathode. So I like to remember it as anox is definitely higher or larger or bigger than a red cat. All right, so this is the one that was higher on table J. Oxidation is losing. So this side's going to lose electrons, and we already said electrons go through the wire. So show the electrons going like this. And reduction is gaining. This side's gaining the electrons. All right, so that's the movement of electrons for us. But we know from writing half reactions that when K loses electrons, it falls apart. The atoms form ions. So I'm going to draw an arrow showing the K, and I can look at this KNO3, or I can look on the periodic table and figure out K's ion charge is a +1. By drawing this arrow, this step is so important in developing good habits at doing this. When you draw this arrow, you are essentially writing the half reaction. So my oxidation half reaction here is K becomes K +1, plus it would lose 1 electron. So there, I did the half reaction on the oxidation side. Now I have to do it. Oh, I want to show one more thing. If these atoms of K are becoming ions out here with a +1 charge, this is actually going to lose mass. It's going to get smaller and smaller in size. And I want you to think about oxidation. When you hear about oxidation in normal everyday life, it means rusting. And when something rusts, the metal actually falls apart. So our anox falls apart, and this side is going to lose mass because atoms form ions. All right, now I want to go over on this side. I want to use a different color. All right, TiNO3 tells me that the ions over here are Ti +2 ions. And if I have reduction and I'm gaining electrons, the arrow has to go this way. So on this side, ions form atoms. I have a saying that I think will help you remember this. The red cat gets fat. And imagine all of these atoms forming on here. This side is going to gain mass. Sorry, my pens aren't working. Gain mass. Okay, and then because I drew this arrow, and remember I got the 2 because I crisscrossed this up, and that's where the +2 came from. So now I can write my reduction half reaction. Ti +2 plus 2 electrons would make Ti. All right, and then the last thing is really something new that I want to teach you too, is how you put these two reactions together and make a balanced skeletal reaction. And we've done balanced skeletal reactions before, but we didn't start with two halves that weren't equal. And by not equal, I mean this side is gaining 2 electrons and this side's only losing 1. So if I want this number to go to 2, I just double everything. 2 of those means 2 of those means 2 of those. And now I have 2 electrons. And so now I want to put these two together. So before the arrow, I have Ti +2. My 2 electrons and 2 electrons are going to cancel out, so I don't have to put that. I put 2 Ks become, after the arrow, I've got a Ti, and after the arrow, I've got 2 Ks at +1. When you are done with a balanced skeletal reaction, you should be able to add up the charge on the left, and it should equal the charge on the right. So over here, Ti with a +2 is a +2 charge. 2 Ks are a 0. So I just have 2 pluses on this side. And over here, I have a 0 plus 2 +1s would be a +2. So 2 equals 2. So I know that this is right. Okay, we're going to go through and do a whole bunch of these together. And the worksheet that I gave you has them already drawn. You're welcome. I know you wouldn't want to sit there and draw these every single time. So instead, you're going to have to go through and do all the steps. So the next one, let's pick 2 metals. So I'm going to put Mg here, and I'm going to put Cu here. And I'm going to tell you that this solution is MgCl2, and this solution is CuCl3. All right. First thing I always have to do is go look on table J, which one's higher, Mg or Cu. So I go over here, I'm going to erase my last one, and I'm going to fill in my new one. Here's Mg, and here's Cu. So this is definitely reduction, and this is definitely oxidation. So I go to my drawing. Mg is going to be my anox, and this side is going to be my red cat. The oxidation loses electrons, so electrons always go from the anode to the cathode, A to C. All right. Oh, you know what I never showed you? An anode, when it is a voltaic cell, is negative, and a cathode, think of that, T, is positive. So the electrons are drawn towards the positive. That makes a lot of sense. So that's where you get those charges on there. Okay, now I need my ions. So if this is MgCl2, this is an Mg +2 in here. And over here, this one has a 3. So Cu +3. All right, and I know I just made this up. I better I better change this. Copper doesn't have a +3 choice. That was not very good writing on my half. CuCl2. All right, which would mean that this is a Cu +2. Okay, I had to change that because on the periodic table, Cu +3 isn't a choice, so I can't have that. All right, now the oxidizing side is going to fall apart. So I draw the arrow this way, showing that these atoms are going to form these ions. And over here on this side, I draw my arrow this way. Once you've drawn your arrows, it's really easy to write your half reactions. Oh, and I'm going to put ions up here because ions move back and forth so that it doesn't build up too much charge on either side. All right. Down here, this is my oxidation half reaction. So Mg, arrow Mg +2, plus that would lose 2 electrons to go from a 0 to a +2, and one of them would be 2 electrons. And then over here, again, just follow your arrow. Cu +2 plus 2 electrons becomes Cu. These ones are already balanced, 2 electrons, 2 electrons. So when I put it together to get my balanced skeletal reaction, it would be Mg plus Cu +2 becomes, after the arrow, I've got Mg +2 plus just Cu. So that would be my balanced skeleton reaction. I'll do another one with you. All right, let's say this one is Al. And so my solution would be AlCl3. And then over here, let's say this one's nickel, Ni. And let's say this solution is NiCl2. All right, go to table J, find Al and Ni. All right, so I'm going to erase this one and erase this one. Okay, I'm looking for Al and Ni. Oh, here's Ni. And where's Al? Oh, there it is. So Al is higher. So this is my ox. And this is my anode. And this one is going to be my reduction. This one is going to be my cathode. So Al is higher than Ni. So that means this is going to be my anode. This is negative. This is where oxidation happens. And over here, this is my red cat. So I'll write out the word cathode just so I practice it. The first thing I like to show is the oxidation loses electrons. So electrons go through the wire from A to C, from the negative to the positive side. My ions can go back and forth inside of here. And then I need to show the ions. So this would be Al with a +3. You can look it up on the periodic table, but you don't have to because this 3 tells me that this was a +3. All right, the one that's oxidizing falls apart and loses mass. So I draw my arrow like that. This would be Ni, that 2 would cross up. So this is Ni with a +2, and the arrow would go like this, and this side would gain mass. All right, when I write my half reactions, Al becomes Al +3 plus 3 electrons. That's my oxidation half reaction. And over here, Ni +2 plus 2 electrons would give me Ni. Then to put it together, to put this together, a 3 and a 2, the lowest number that I could have in common between them is 6. So I need both sides to get to 6. So to get 3 to go to 6, I'm going to double it. So 2 times 3 is 6. 2 times 1 is 2. 2 times 1 is 2. So that's what I get if I double this one. And if I want this to get to 6, I have to multiply it by 3. So this was times 2. This side's going to be times 3. So put a 3 here. 3 times 2 is 6. And put a 3 here. And now put it together. Before the arrow, I have 2Al. And before the arrow on this side, I have 3 Ni's at +2. After the arrow, I have 2 Al's at +3. And I have 3 Ni's. Just to do the math, to check and make sure I did everything right, this 2 Al's right here, this is no charge. 3 plus 2's would be a +6. 2 plus 3's would be a +6, and this is 0. So that means I did the balancing right and I did the reactions right. So I want you to go through and do the rest of the practice this week. I always have a Zoom every single Friday at 1. So if you want some extra help, please join me on the Zoom, or never hesitate to ask me questions. You can message me on Schoology and I would be happy to answer any questions that you have. Bye guys, miss you.